All right, today we're going to tackle one of C-Sharp's most powerful and maybe a little misunderstood features, delegates. Look, if you've ever found yourself wishing your code was more flexible, more reactive, well, you are in exactly the right place. Let's dive in.
So let's start with a problem that I guarantee every single one of us has faced. You've got different parts of your program, right? Different classes, different components, and they all need to communicate. But how do you get one part to tell another, hey, something just happened, without creating this tangled, permanent mess of wires between them?
To really see what I'm talking about, let's look at a classic coding problem. And we'll use a simple little game scenario here, because it really highlights this whole communication issue perfectly.
Okay, so picture this. You've got a player class in your game, and inside it, there's this add points method. Now, when the player's score crosses 100, this one method has to do everything. It has to directly call the UI to pop up a message, and it has to call the logger to write to a file. The poor player class is totally burdened. It has to know the nitty-gritty details of all these other classes.
Right? So what happens next? Your boss comes along and says, hey, let's add a sound effect, or let's add a little party celebration. What do you have to do? You've got to crack open that player class again and just keep stuffing more code into it. This, my friends, is what we call tight coupling, and it is an absolute recipe for disaster. Your player class just becomes this fragile, clunky bottleneck.
So, how do we get out of this mess? Well, this is where the hero of our story makes its grand entrance, the delegate. This is the C# feature that was literally designed to solve this exact problem and to do it in a really clean and elegant way. Now, if you look at the official documentation, you'll see something like, a delegate safely encapsulates a method, which is fine, but let's break that down. A much simpler way to think about it is this. A delegate is just a special kind of variable, but instead of holding data like a number or a string, it holds an entire function.
And this right here makes it crystal clear. I mean, look at this. On the left, you've got your standard variable, right? Int score equals 100. Simple. But look at the right. We have a delegate variable called notifier, and it's holding the entire showAchievement method. You are literally treating a function just like it's a piece of data. That's the key idea.
Okay, so how do you actually make one of these things? You just use the delegate keyword, and then you define the signature. That's the shape of the methods it's allowed to hold. So, for our example, this achievement unlocked handler can only hold methods that take one integer and return nothing, void. It's like a contract, a rule that any function assigned to it has to follow.
But here's where it gets really cool. The true magic of delegates isn't just that they can hold one method, it's that they can hold many methods, all at the same time.
Check this out. Using the simple plus equals operator, you can build what's called an invocation list. So we start with our handler. First, we just assign the UI's method to it. Then, we use plus equals to tack on the logger's method, and then we do it again for a party method. Just like that, our single handler variable now holds references to all three of those functions.
And this is the magic moment. Back inside our player class, all that messy, ugly, tightly coupled code, it's gone, vanished, replaced by this one, single, clean line of code. The player class is now completely, blissfully unaware of the UI, the logger, the party. It doesn't care. It just calls its handler.
And boom, this is the power of what we call multicasting. That one little call to handler triggers the entire chain of methods we added. Our player class is now totally decoupled. That maintenance nightmare we started with, a thing of the past. Now we can add new listeners or take them away without ever having to touch the player class again.
Now, this whole idea, this publisher-subscriber pattern, it's so incredibly useful that C# actually has a special feature built right on top of delegates to make it even better. And I bet you've already heard of them. We're talking about events.
The easiest way to think about an event is that it's just a delegate, but with guardrails. It's a safer, more controlled way to expose this notification system. For example, an event stops some other class from coming along and accidentally wiping out your entire list of subscribers, which a public delegate would allow.
And you can see just how closely related they are from the syntax. You declare it with the event keyword. But notice, it's still based on our achievement unlocked handler delegate type. And subscribing, it's the exact same plus equals operator. At its core, an event is pretty much just a safe wrapper around a delegate.
So if there's one thing to remember, it's this powerful one-to-many relationship. You have one object, our player, that raises one single event, And that one event, which is secretly powered by a multicast delegate, can then notify many different subscribers. And the best part? The player knows absolutely nothing about any of them.
Okay, so why does this matter? Why have we spent all this time on delegates? Because once you really, truly get this concept, it completely unlocks a more flexible, more powerful way to think about designing your software.
This idea of decoupling, it's really the bedrock of good software design. It's what lets you plug in new features without breaking everything that's already there. It lets you build event-driven systems, where your whole application just reacts to things happening, instead of following one rigid script. Heck, it even opens the door to functional programming ideas, where you can start passing around behavior itself, not just data, as a parameter to your functions.
So in the end, delegates aren't just some random C# feature. They're a tool for thought, a new way of looking at a problem. They empower you to build systems that are more modular, way more resilient, and so much easier to maintain in the long run. So the real question is, now that you know you can pass functions around like data, what new kinds of solutions can you build?